Hello friends, let's balance one more equation. This equation is for the reaction between carbon and concentrated nitric acid. The reaction given, carbon reacts with nitric acid. As a result, the products are carbon dioxide, water and nitrogen dioxide. This chemical equation, if we follow the traditional trial and error method or hit and trial method, we cannot balance easily. Let's check now. I have noted down the atoms present on the reactant side as well as the product side. They are carbon, nitrogen, hydrogen and oxygen. Now let's check the atoms on the left hand side as well as the right hand side. Carbon at the left hand side, one atom. Carbon at the right hand side also only one atom. Nitrogen at the left hand side, one atom. Nitrogen at the right hand side also one atom. Hydrogen at the left hand side, one atom. Hydrogen at the right hand side, two atoms. In water, two hydrogen atoms are there. Oxygen at the left hand side, three atoms. Oxygen at the product side, 2 plus 1 plus 2, 5 atoms. That is, at three different places they are present. At one place it is 2 times. At one place it is 2 times. It's 2 times at one place. Another place it is 1 time. Another place again 2 times. 2 times, then 1 time, then again 2 times. When we check hydrogen at the right hand side 2 times, but the left hand side 1 time, therefore we can multiply this 1 into 2. So this 2 has to be written as a coefficient of nitric acid. So when we multiply this 2 by the nitric acid, then what are the atoms will change at the left hand side? Nitrogen will change. This 1 will become 2 times now. And oxygen also will change. 2 times 3 is equal to 6 times. The right hand side nitrogen only 1 time, but the left hand side 2 times. So in order to make it equal, we can multiply by 2 times. It's multiplied by 2 times. So that 2 has to be written here. Now when we multiply this nitrogen dioxide by 2, what happens? 2 times 2, 4. That is, this 2 has become 4. Now when we check both the sides, carbon both the sides equal. Nitrogen both the sides, 2 atoms equal. Hydrogen both the sides, 2 atoms equal. Oxygen at one side 6 times, another side 2 plus 1, another place 2 plus 1, 3 plus 4, 7 times. Here it is 7 times, but the left hand side 6 times. So oxygen is not balanced. Now if we try by this method, it takes much time to balance. Therefore, we need to go by another method. By that method, what's that? First of all, this nitric acid is a strong oxidizing agent. So as it's a strong oxidizing agent, it will supply nascent oxygen atom. So this nitric acid first, it will decompose to supply nascent oxygen atom. So this equation, we can write in two steps that we can see at the next page. At two page, first of all, this nitric acid will split into this HNO3. This is concentrated nitric acid. If concentrated nitric acid decomposed, it will give water, then nitrogen dioxide, then nascent oxygen. So this is the first step of decomposition of nitric acid, concentrated nitric acid. First of all, this equation we need to balance. Now, right hand side, two hydrogen atoms. Therefore, this nitric acid, the left hand side, here it is only one hydrogen. So what we need to do, this nitric acid has to be multiplied by 2 times. When we multiply this nitric acid by 2 times, then what change takes place? Nitrogen at the left hand side becomes 2 times, but the right hand side, nitrogen is only 1 time. Therefore, what has to be done? This nitrogen dioxide has to be multiplied by 2 times. Now, when we check hydrogen both sides, 2 atoms, nitrogen both sides, 2 atoms, oxygen left hand side, 2 3s are 6, right hand side, in water 1 oxygen, in nitrogen dioxide 2 times 2 4 oxygen, so 4 plus 1 5, 5 plus 1 at the nascent oxygen 1 more oxygen, so 5 plus 1 6. So all the atoms are equal. Now this equation is balanced. Now this nitric acid, it reacts with the carbon. So which will react with the carbon? The nascent oxygen supplied in the first step will react with carbon. That is, it will oxidize this carbon. So the second step, this carbon reacts with this nascent oxygen. As a result, we will get carbon dioxide. Now the second step, once again, we need to balance. Carbon both sides 1 atom, oxygen at the right hand side 2 atoms, but at the left hand side only 1 atom. Therefore, what has to be done? This nascent oxygen has to be multiplied by 2 times. Now the second equation is balanced. Now at the second equation, the second stage, what we have got, that is, we can number the equation. We can number, this is equation 2, second equation. This is equation 1, the first equation. At the equation second, we have got 2 moles of nascent oxygen. These 2 moles of nascent oxygen, this moles of the nascent oxygen was obtained from the first step. At the first step, we have got nascent oxygen. By the decomposition of nitric acid, concentrate nitric acid, we have got water, nitrogen dioxide, oxygen. Water, nitrogen dioxide, oxygen. So, that nascent oxygen only is used up at the second stage. Therefore, here at the second stage, what we have got, 2 moles of nascent oxygen. But at the first step, only 1 mole of nascent oxygen only is there. Therefore, what has to be done? The first step, nascent oxygen also must be 2 moles. So what we need to do, this nascent oxygen, the first step has to be multiplied by 2 times. But when we multiply at only one place, the value will change. Therefore, the whole equation, the first equation, needs to be multiplied by, what is that? By 2. The whole equation is multiplied by 2 times. So as a result, this nascent oxygen will become 2 times. This nitrogen dioxide will become 4 times. This water will become 2 times. This nitric acid also will become 4 times. Now we need to add both the equations. So both the equations we need to add together. While we are adding the equation, the same substance on the opposite side will be cancelled. So the first step, we have got 2 moles of nascent oxygen at the right hand side. At the second step, 2 moles of nascent oxygen at this reactant side, left hand side. So same substance, 2 moles of nascent oxygen, but they are at the opposite side, so we can cancel it. Remaining substance we need to write as it is. Remaining, what is that? Remaining substance, that is the first carbon, plus at the second stage carbon is left out at the reactant side. At the first equation, at the reactant side, what is left out? Nitric acid, that is 4 moles of nitric acid. 4 moles of nitric acid gives, at the second stage, what is left out at the product side? Carbon dioxide, 1 mole of carbon dioxide, plus at the first step, what are the products left out? 2 moles of water, 2 moles of water, and 4 moles of nitrogen dioxide, 4 moles of nitrogen dioxide. That is the balance equation. Now when we check the atoms on the left hand side as well as the right hand side, all the atoms will be equal. Carbon left hand side 1, right hand side also 1. Hydrogen left hand side 4 hydrogen, right hand side also 2 times 2, 4. Nitrogen left hand side 4 nitrogen, right hand side also 4 nitrogen. Oxygen left hand side, it is 12 times, and right hand side here 2 times, plus here 2 times, here 4 times 2, 8. That is right hand side also 12 times. So all the atoms on the reactant side as well as the product side are equal. So now the equation is balanced. So the balance equation for the reaction of carbon with nitric acid is 1 mole of carbon plus 4 moles of nitric acid. As a result, 1 mole of carbon dioxide and 2 moles of water and 4 moles of nitrogen dioxide are obtained as a product. Thank you so much for watching.